pretty easy, right? If I give you a table like this, and I want to know the percentage, of oxygen, in the total atmosphere, you multiply whatever percentage is by whatever the total is. So if I said it was 760, it's 21%. 21% times 760 is that. If I say it's in humid air and I give you a volume, which I will, of how much of it is water, you subtract that first and then multiply. Plenty of practice problems on that. I'm not going to redo that. So that's fine. The second one as well is, and really exists on this. Again, you have these practice problems. P1 V1 equals P2 V2. I give you 3 of them. You use algebra to solve for the 4th. So the one that is more complicated, and the best thing is to show it this way, is this one. So do I have this white? So we have so it's pretty much over here. So you have 4 volumes. Again, you have it on this, you have it on other things as well. Again, the tidal volume is the volume of the normal breath. How much more you can inspire than your normal inhalation, inspiratory reserve volume. How much more you can expire versus a normal breath is your expiratory reserve volume. And finally, the last one, your residual volume, is what air remains in your lung even if you expel all the way. Okay, vital capacity. Okay, total capacity is all these. Vital capacity, I'm going to sort of put in this. It's 3 of them. Okay, it's basically, and this is sort of this idea: if you inhale as much as you can and exhale as much as you can, that's going to cover IRV, tidal volume, expiratory reserve volume, everything but residual volume. That's going to be vital capacity. Okay, and overall, we're going to put the different diseases on this, but that's vital capacity, and that is actually what we like to measure. We measured the other ones, etc. But vital capacity, again, all 3 of those volumes. You inhale as much as you can, and you exhale as much as you can. Now, we do care, as we do this, for looking at obstructive versus the 2 different lung diseases. Obstructive versus restricted, we don't just care about how big the vital capacity is. We want to know how fast you can exhale. So if you do time, how much of your vital capacity could you get out in 1 second? So 2 equations, and then we sort of have a column chart to figure out what diseases you have with it. So the first equation is the idea of your FEV 1.0, this is 1 second. This is forced expiratory volume. I think I have it up here as far as words go. Okay, kind of up there. How much FEV, how much you can get out in 1 second? And the calculation for that is basically what is the volume you got out in 1 second, okay, 1 second, over your measured vital capacity, which means these values you're actually getting in your spirometer, times 100. Okay? The other equation we're going to use to determine these diseases is how, basically, when you look at your vital capacity, how is it compared to what is expected to be? Are you able to actually, inspire as much and expire, or is it sort of compromised where your vital capacity is good? So it's sort of, again, looking at then, this is equation 1. Equation 2 would be now, what is your measured vital capacity over your expected or predicted vital capacity times 100. Okay? And again, I'm going to be giving you like values of like FEV 1.0, well, how much you got in 1 second. I'll give you these values to know measure vital capacity, like these 3 volumes. and I will give you the predicted. You're not going to look at a chart. So I'm giving you all those values. So then comes calculating restrictive versus obstructive. So for some reason I like to write obstructive first. I'll write obstructive, lung disease versus restrictive. And literally, I'm going to put a sentence to remind us of what this could be. But really look at these two equations because we're going to do above or below normal. So FEV 1.0 percentage versus whatever we want to call this. I'm just going to call it vital capacity. This is equation 2. That's equation 1. Let's write them both. And here's our, vital capacity, compared to predicted. Those are the two equations. So for obstructive, I don't know which one okay, it's kind of shown there if you like words. So you are obstructing expiration. So I put the other examples. Yeah, I put them at the bottom there. So just because I want to rewrite everything here. So basically, you're able to inspire. You're able to expand your lungs to get you to basically get air in, and potentially you can get it out too. But the idea you can't do it as fast. Basically, you're limiting, you're obstructing expiration. Okay, you're limiting the pathway. You got emphysema, you can't basically get it out. COPD, asthma. The idea is you should be able to inspire, might be slower, up to your full capacity here, and even exhale, but you cannot do it very fast. It's like you're breathing through, a coffee straw. So for obstructive, you are going to have potentially a below normal. Okay, basically anything below. I'll write this like below 70% of either of these would be considered abnormal. You will have a below normal FEV 1.0 percentage, but you have a higher range. You'll have a normal, vital capacity compared to predicted. So this one will be, your measured one over this predicted value I give you will be more than 70% in this case. But when you calculate your measured vital capacity based upon all these numbers here, and look how much you got in 1 second, that will be compromised. Below normal FEV 1.0, normal vital capacity, it's going to be an obstructive one. It could be COPD, asthma, emphysema, etc. Alternatively, a restrictive, you want to think of restricting inspiration. Okay, now we're not able to expand basically our thoracic cavity to inhale. I won't bring that model back as much as we can. And again, when you look at that, instead of writing these down, you have this PowerPoint. The idea of, you have fluid, so you can't expand. You have lung fibrosis, so you don't have the elasticity in your lungs. Even things which might not be disease, but things like pregnancy or obesity, in the sense of not being able to basically have your diaphragm, descend as much as it is, that's going to limit how much you can inspire. Okay, so those are good examples of that. So in that case, the idea is this is what's being, you're limiting this. You're not able to get as high. But when we say blow it out as fast as you can, that is not compromised. Okay, expiration is not. So restrictive, we're restricting inspiration. You will have a normal, which means we'll be above 70%. You'll have a normal FEV, but now you'll have a below normal vital capacity, which means when you look at this equation, your measured vital capacity over the predicted value I give you times 100 will be below 70%. Okay? And so those questions literally are giving you those values. You're going to calculate these, and then basically these are all multiple choice again. You're going to be telling me based upon that, do you have an obstructive, restrictive, neither or both? I'm not going to give both. I'm not going to give neither. That's no fun. You're either going to have a restrictive or an obstructive lung disease.
The second equation, what is that for?
That's determining, that's why I sort of put VC. This is basically, is your capacity, you know your capacity is this whole thing, right? How much you're gonna have of sales. Is that within normal range based on what you predicted? Yeah, it's predicted. Is this close to what at least is predicted? Remember we had that written prediction, you know, based upon that little chart. You're obviously not gonna have to do that. I'll literally tell you, you know, I'll tell you, let's say we have.
The top one is to determine FEV.
Yeah, how fast you get it out. So again, if I sort of just gave you a, I'll say, again, I might give you the pieces, they add these up. But if I say the measured biocapacity was 3 liters, your predicted biocapacity was 4 liters, and your FEV 1.0, basically how much you get out in that first second, was 2 liters. Okay, we have those values. We're going to be able to know what these are, then calculate them and determine if it's obstructive or restrictive. So the first equation, when we're looking at this, okay, basically it's how much of the measure we got in 1 second. Okay, so we got 2 out of the 3. 2 liters over 3 liters times 100. So 66.7%, right? Again, you might have to like add these things up to get those 3 together, but overall that's what you'll have measured. I have to give you FEV1. We're not looking at a spirometer or anything like that. So that's 66.7%. Okay, when we do the second equation on this, it's going to be measured over predicted. That's going to be 3 liters over 4 liters times 100 equals 75%. Okay, I'll be giving you the value. Anything under 70 is below normal. So, what does this person have? Obstructive, restrictive, neither or both? Obstructive, right? This is below 70%. Again, this is above it, and boom, we have it. So it's obstructive, could be asthma, COPD, etc. All multiple choice. Make sense?
But the one that's 75%, why are we not using that one?
Because it's well, we are, but it's basically above 70%, so it's within normal range. So you're looking, and I'll give you the value. Anything below 70%, which that's going to be the problem. Okay, and so in this case, and I'm not going to have both, and I'm not going to have neither, because I don't want to. I don't need to for you to get this concept here overall. So that's that. Yeah, I do want to see my granddaughter. It's not for 2 weeks. You've done most, but you know, over the see where you are. And have a happy Thanksgiving. See where you're all, and the week after on that week report, see if you need more